Hello students, Professor Nugent here. In this video, we're going to discuss classical linear model assumptions. These are assumptions that are going to allow us to make inference with our multiple regression model. So the classical linear model assumptions are basically the Gauss-Markov assumptions, which are the first five: linear in parameters, random sample of n observations, no perfect collinearity, and I've added, we need a large enough sample so that we can solve our first order conditions uniquely, zero conditional mean. So our expected value of u given the x's is 0, and homoscedasticity. So the variance of u given x is constant. These are the five here in black are our Gauss-Markov assumptions. We're adding a sixth, which is normality, we have here in red. We are assuming that the error term u is normally distributed with a mean of 0 and a variance of sigma squared. All right, so we're adding in this sixth assumption, and we bring this in really to make our lives easier. This is going to make working with the sampling distributions a lot easier. We don't absolutely need this assumption. If we have large enough samples, then if the errors are close enough to normal, then that is good enough to be able to make inference using these tools. So what we want to be able to do is we want to carry out some hypothesis tests. We want to carry out a t-test or an f-test. We'll carry out a t-test if we are carrying out hypothesis tests with just one restriction. So if we're testing the statistical significance of just one coefficient, or if we are testing, we can test whether the values of two coefficients are equal using a hypothesis test with just one restriction. And we can do that with a t-test. We may refer to the student's t-distribution if all of the classical linear model assumptions are satisfied. So we have homoscedasticity and normality in the error term. We will use degrees of freedom n minus k minus 1, where n is the sample size, k is the number of parameters estimated, the number of variables for which we have estimated parameters in the model, minus 1. The student's t-distribution and normal distribution will be very close once degrees of freedom are about 120. So after degrees of freedom reach 120, we can just refer to the normal distribution. When we start carrying out hypothesis tests with multiple restrictions, so if we want to test the joint statistical significance of several coefficients, then we need to carry out an f-test, and we're going to refer to the f distribution, and we have two sets of degrees of freedom. We have q, which is the number of restrictions. So if we're testing the statistical significance of two coefficients, then we have two restrictions here, q equals 2 and n minus k minus 1, which is the same as for student's t-distribution. You can obtain these critical values from any statistical software, including Excel, where you can use the equals f dot inv equals t dot inv, and I believe this is equals norm dot inv to get your critical values, and you'll use, for 5% level of significance, 95% probability, because we're working with cumulative probability for a one-tailed test. For a two-tailed test, that'd be 975. 975 for that 0.025 or 2.5% probability in the tail. All right, so that's it for the assumptions. Stay tuned to the next video, and we will review carrying out hypothesis testing on multiple coefficients. Thank you.